Hello children, today we are going to discuss chapter electricity. First we will discuss about types of charges. There are two types of charges, positive charge and negative charge. Positive charge, these are made of subatomic particles like proton. Negative charge, these are made of negatively subatomic particles like electrons. And when opposite charges are there, then between opposite charges force of attraction will develop. SI unit of charge. The SI unit of charge is Coulomb. An electron possesses a negative charge of 1.5 into 10 to the power minus 19, and the SI unit of 1 Coulomb is equivalent to the charge containing 6.25 into 10 to the power minus 18. Now we will discuss conductors and insulators. Conductors. These substances have the property to conduct electricity through them. Insulators, the substances that have the property to obstruct the flow of electricity. Conductors have free or loosely held electrons which help in conducting electricity. But in insulators, they don't have free electrons. For example, the conductors like copper. Metals are the example of conductors. And the example of insulators are rubber and plastics. Metal, copper is a conductor and rubber, that is insulation. Electric potential. When a small electric charge is placed in the electric field due to another charge, it experiences a different type of and a special type of force. So, work has done on the positive charge to move it against this force of repulsion. The electric potential is defined as the work done in moving a unit positive charge from infinity to that point. Potential difference. The concept of electric potential is closely linked to that of the electric field. A small charge placed within an electric field experiences a force, and to have brought that charge to that point against the force requires work. The electric potential at any point is defined as the energy required to bring a unit test charge from an infinite distance slowly to that point. It is usually measured in volts, and 1 volt is the potential for which 1 joule of work must be expended to bring a charge of 1 coulomb from infinity. So, the potential difference is equals to work done upon quantity of charge moved. Potential difference is V and W is a work done. Charge is Q. SI unit of potential difference is volt. 1 volt is equals to 1 joule upon 1 coulomb. Voltmeter. A voltmeter is an instrument used for measuring electrical potential difference between two points in an electric circuit. Voltmeter has a high resistance so that it takes negligible current. So voltmeter is used for measuring potential difference. Electric current. The movement of electric charge is known as electric current, the intensity of which is usually measured in amperes. Current can consist of any moving charged particles. Most common are electrons, but any charge in motion constitutes a current. 1 ampere, ampere is the unit for current. 1 ampere is equals to 1 coulomb upon 1 second. Ammeter. Ammeter is a measuring instrument used to measure electric current in a circuit. Electric current are measured in amperes, hence the name as ammeter. An ammeter should have a very low resistance so that it may not change the value of current flowing in the circuit. Circuit diagram. We know that an electric circuit comprises a cell, battery, plug, electric components, and connecting wires. It is often convenient to draw a schematic diagram in which different components of circuit are represented by the symbols conveniently. Conventional symbols used to represent some most common used electric components. This is the circuit diagram. Here we used the symbols of the components which are there in a circuit. These are the symbols of the components: electric cell, battery, plug when switch is on, and condition when switch is off, wire, wire crossing without join, electric bulb, resistance, variable resistance, ammeter, and voltmeter. What is Ohm's law? This law explains the relationship between voltage, V or E, current, and resistance. Used by electricians, automobiles, technicians, stereo installers. According to this law, a constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its end. Like according to Ohm's law, V proportional I and V is equals to Ri, where R consists resistance of a conductor. This can also be written as I is equals to V upon R, and current I is equals to V upon R. So the current is directly proportional. Current is directly proportional to the potential difference, and this current is inversely proportional to the resistance. What is resistance? An electron traveling through a wire and loads of the external circuit encounters resistance. Resistance is a hindrance to the flow of charge. For an electron, the journey from terminal to terminal is not a direct route. Rather, it is a zigzag path that results from countless collisions with the fixed atoms within the conducting materials. The electrons encounter resistance, a hindrance to their movement. SI unit of resistance is ohm. This is the symbol of ohm. Factors affecting resistance: length of conductor, area of cross section of a conductor, as well as we can speak thickness of our conductor, nature of the material of the conductor, and the temperature of conductor. Resistivity. The resistance of a given conductor is directly proportional to the length. Resistance of a given conductor is directly proportional to the length. Here R is the resistance and L is the length. Now, the resistance of a given conductor is inversely proportional to the cross-section area. Here R is the resistance and A is the cross-section area as well as thickness of a conductor. Now, we have a two equation. Equation first, R proportional L. Equation second, R is inversely proportional to A. By combining both the equations, that is R proportional L upon A, then R is equals to rho into L upon A, where rho is a constant known as resistivity of the material. The resistivity of substance is numerically equal to the resistance of a rod of that substance, which is 1 meter long and 1 square meter in cross section. So We have the resistivity rho is equals to R into A upon L. The unit of resistance is ohm. The unit area of cross section, that is meter square, and the unit of length is meter. So by putting all these values, unit of R is ohm, unit of A is meter square, and unit of L is meter. So the unit of rho is ohm meter. So the SI unit of resistivity is ohm meter. This is the symbol of ohm. Now the resistivity of alloys are much more than those of the pure metals from which they are made. For example, the resistivity of magnin, which is an alloy of copper, manganese and nickel, is about 25 times more than that of copper. Alloys are used in heating a material, as alloy have a very high resistivity, due to which heating element produce a lot of heat on passing current. And alloys don't undergo oxidation easily even at high temperature. Now combination of resistors. Resistors can be combined in two ways. First in series, another is in parallel. Now first we will discuss resistors in series. When two and more resistors are connected end to end consecutively, they are said to be connected in a series. According to the law of combination of resistance, in a series, the combined resistance of any number of resistance connected in series is equals to the sum of the individual resistances. See, suppose this R is a combined resistance, so this R is equals to the sum of all the resistance, all the individual resistances. When a number of resistors connected in a series are joined to the terminal of battery, then each resistance has a different potential difference across its end, which depends on the value of resistance. But the total potential difference across all the ends of all the resistors in series is equal. When a number of resistors are connected in series, then the same current flows through each resistance. Now we will calculate resultant of resistance connected in a series. See, suppose these three resistance are there. So V is equals to V1, V2 and V3. We know V upon I is equals to R. So V is equals to IR. Now we have a value of V. So in the case of V1, V1 is equals to IR1. In the case of V2, V2 is equals to IR2. And in the case of V3, V3 is equals to IR3. We have a values of V1, V2 and V3. Now simply we will put the values of V in the equation. V is equals to V1 plus V2 plus V3. Then IR is equals to IR1, IR2, IR3. I is common. Then I into R1 plus R2 plus R3. So R is equals to R1 plus R2 plus R3. R is the resultant resistance connected in a series. Now we will discuss resistors in parallel. When two or more resistors are connected between the same points, they are said to be connected in parallel. According to law of combination of resistance, in parallel, the reciprocal of the combined resistance of any number of resistance connected in parallel is equal to the sum of the reciprocals of the individual resistances. Here, R is the resultant resistance. So 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. When a number of resistances are connected in parallel, then their combined resistance is less than the smallest individual resistance. Now we will calculate resultant resultant of resistances connected in a parallel. See here I1, I2, I3. So the total current is I is equals to I1 plus I2 plus I3. We know very well I is equals to V upon R. So in the case of I1, V upon R1, I2 V upon R2 and I3 V upon R3. Now putting the value of I in equation 12.15. Then V upon R is equals to V upon R1 plus V upon R2 plus V upon R3. So now 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Parallel and series connections. What is the difference between parallel and series? If one electric appliance stops working due to some defect, then all other appliances keep working normally in parallel. But in series, if one electric appliance stops working due to some defect, then all other appliances will stop. In the case of parallel circuit, each electric appliance has its own switch due to which it can be turned on or off independently. But in series, all the electric appliances have only single switch due to which they cannot be turned off separately. In the case of parallel, each appliances get same voltage as that of power source. But in the case of series, the appliances do not get same voltage as that of power supply line. In the case of parallel, overall resistance of the household circuit is reduced due to which the current from power supply is high. But in the case of series, the circuit and the overall resistance of the circuit increase due to which the current from the power source is low. Now, heating effect of an electric current. When electricity passes through a high resistance wire, like a nichrome wire, the resistance wire becomes very hot and produce heat. This is called the heating effect of current because the production of heat is only because of the flow of current. Now, the heat produced in wire is directly proportional to the square of current and resistance of wire as well as time for which current is passed. There are many practical uses of heating effect of current. Some of the most common are an incandescent light bulb glows when a filament is heated by heating effect of current. So hot that glows white with terminal radiations, also called the black body radiation. This is known as black body radiation. Electric stoves and the other electric heaters usually work on the heating effect of current. Electric irons and heaters are often worked only because of the heating effect of current. Electric fuse rely on the fact that if enough current flows, enough heat will be generated to melt the fuse wire. And electronic gadgets usually work by heating effect of the current and vaporizing propylene glycol and vegetable glycerin. Now, thermistors and resistance thermometer are the resistor whose resistance change when the temperature changes. These are sometimes used in a conjunction with heating effect of the current, also called self-heating. In this context, if a large current is running through a non-linear resistance, the resistor's temperature rise and therefore its resistance change. Then these components can be used in a circuit protection role similar as fuse for feedback in circuit or for many other purposes also. In general, self-heating can turn a resistor into a non-linear and a hysteric circuit element. Electric energy. What is this electric energy? Heat is equals to H is equals to I2, where H is heat and I is current. H is equals to I square RT gives the rate at which electric energy is dissipated or consumed in an electric circuit. This is also termed as electric power, and we can represent this power via P. So P is equals to VI, P is equals to I square R, and P is equals to V square upon R. The SI unit of electric power is what? It is the power consumed by a device that carries 1 ampere of current when operated at a potential difference that is 1 volt. Thus, 1 watt is equals to 1 volt into 1 ampere. The unit watt is very small, therefore in actual practice we use a much large unit that is called kilowatt. It is equals to the 1000 watts. Since electric energy is the product of power and time, the unit of electric energy is therefore watt hour. 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour, and the commercial unit of electric energy is kilowatt hour, commonly known as kWh. So, dear children, this is the